Okay, so in this question we asked to find the turning point of this function y equals a minus x plus b squared, and we're told that it passes through 0, 2 and minus 1, 0. So we're to find the turning point of this function here, and it's got these two unknowns, a and b. So generally, how would you find the turning point of a function? Well, the turning point is when the first derivative is equal to 0. So if we actually knew what a and b were, we'd just differentiate this function, find out, set it to 0, and solve for the values of x, where that's equal to 0, and that'll give us a turning point. In this case, we haven't got a and b. So we need to find a, we need to find b, but we have been given these two pieces of information. So there's two unknowns, two pieces of information. There should be enough information for us to solve this problem. So now I like to always start by drawing some sort of a rough sketch. In this case, we know that the function passes through 0, 2, so let's say that's 0, 2 there. And we know it passes through minus 1, 0, so let's say it's minus 1, 0 there. And we know it's a quadratic, and it's a minus x squared, so it's going to be kind of an upside down quadratic. So again, we don't have to be exactly right here, but let's say it looks something like that. We don't have to get exactly right, but I just like to have some idea of what I'm searching for, what sort of function we're looking at. Okay, so let's try and use these two bits of information that we've got here and here to figure out what a and b are. So we know the function passes through 0, 2. So let's do these one at a time. So let's do the 0, 2 first. So we'd say that 2 equals a minus 0 plus b squared, or 2 equals a minus b squared. Seems easiest to isolate a, so we'll bring the b squared to the other side, and a equals b squared plus 2. Okay, let's do the same for the other one, minus 1, 0. So with 0 equals a minus 1 plus b squared, which equals a minus, let's actually just turn that around, b minus 1 squared. Okay, and again, let's isolate the a, so we'll bring all of this over to the other side, and we'll say a equals b minus 1 squared. Okay, so now we've got these two equations, two unknowns, should be pretty easy to solve, and they're both in the form of a, so we can now just make them equal. B squared plus 2 equals b minus 1 squared, and which equals b squared minus 2b plus 1. The b squareds cancel out. That one cancels out with this one, so we get minus 2b equals 1. b equals minus a half, and we substitute that back into either of them. Let's substitute back into this one here. A equals minus a half squared is a quarter plus 2, so 2 1/4. Right, so we've done most of the hard work. So now we know that our function is now 2 1/4 minus x plus b. So I'm just going back to this function here, right? X plus b, so x minus a half squared. Is it worthwhile expanding? Yeah, let's expand it. So 2 1/2 minus, okay, x squared minus x plus a quarter, which equals 2 1/4 minus x squared plus x minus a quarter, which equals minus x squared plus x plus 2. Okay, so that's the function y equals minus x squared plus x plus 2. We could just do a quick check to make sure that's right by plugging in the numbers 0, 2. So when x equals 0, y equals 2, that's right. Let's plug in the number minus 1 and 0. So minus 1 squared is 1, but then you've got a minus here, so it's minus 1 plus minus 1 is minus 2 plus 2 is 0, so that's right. Okay, so this is the right function. It's not the answer, because we haven't got the answer yet. The answer is we need to find the turning point. So now, let's look at how we find the turning point. Well, as I said earlier, turning point is when the derivative equals 0. So let's write the function again. Y equals minus x squared plus x plus 2. The derivative equals minus 2x plus 1 plus 0, which we can ignore. Okay, so that's got to be equal to 0. So 0 equals minus 2x plus 1. Let's bring the 2x equals 1, x equals a half. Plug that x equals a half back into the function. And then y equals a half squared. So it's minus a quarter here, because a quarter squared and then it's minus, plus a half, plus 2. Minus a quarter plus a half is a quarter, plus 2 is 2 and a quarter. Therefore, turning point is x equals a half, y equals 2 and a quarter. Okay, so that's the answer. So let's look at it. So we're done now, but let's just check if there's some way that we can verify whether the answer is correct. So the first thing I would look at this graph and say, does that look reasonable? Well, it's in the right kind of ballpark, okay? So we know the function looks something like this, and we're saying the turning point is a half, 2 and a quarter. So it's bigger than 0, which we kind of expect. It's higher up than 2 and a quarter, which is also kind of what we expect. That's probably good enough for checking. The other thing you could do is you might guess that this is 2 zeros. You know, you could plug 2 into this function back here, and you'd find that if you plug 2 in, you get minus 4 plus 2 plus 2 is 0. So that actually crosses the line there. So minus 1 to 2 is, that's 3 units across. And if you were to go 1.5, you'd go 1.5, and that's the turning point. So that is right. So you don't need to do all that extra checking, but if you wanted to be more sure of your answer, you could do that. But good enough just to stop there.